Hello everyone, today I will present my Lab 2 for Physics 2211 about the motion of a falling object. So for the introduction, the purpose of this lab is to observe an object falling down and experiment, and then using tracker to analyze the object's motion, and then using 3 computational models to analyze that, and then apply the fundamental physics principle, determine the effect of gravity and drag on the motion of an object. So the fundamental physics principles, the first one is about the Newton's second law. So for the net force is equals to change in momentum divided by the change in time. And then we can also derive the velocity update formula and the position update formula from that. And then for the gravitational forces, so the gravitational forces near the Earth's surface is equals to the mass of the object times the acceleration due to gravity, and then the direction is pointing downwards. And then there's also the drag force in this experiment because there's a time, like the air resistance when the object's falling down. And the formula is the v times the square root of the magnitude of the velocity. And in this case, the drag force is pointing upwards. So the preview of the main result is on the right picture. So the body is released from the rest with the gravity, and also the forces on the body during the acceleration has the gravity, and also the drag force pointing upwards. The gravity is pointing downwards, and then the body tends to speed up since the gravity, and the drag force will be also increased. Yeah. And then in this lab, the system is the object with the speaker that I will just released later. And then also the surroundings are everything else. For the initial conditions, the mass of the object is 0.209 kilograms, and initial position, like on the y direction, is negative 4.731926 times 10 to the negative 2. And the video frames per second is 30, and start time is 0, and final time is the 0.433 seconds, which is the time when the object fall to the ground. So here's the analysis of motion using the tracker, and I kind of track that in each time interval. So here's the computational model for the gravity only one. So I first define the mass, which is 0.209, and also the position, the velocity. The velocity is 0, and then also like the acceleration due to gravity, which is 9.8, and the j hat is like 0, 1, 0 in positive y axis. And then since the air resistance in this case, I set it to be 0 because we just want to measure the gravity. And then on the right-hand side is about, like in a while loop, the time is within like 0.433 seconds. And the net force is the mass of the ball times the gravity acceleration due to gravity in negative y direction. And then also we need to update the velocity and the position in its own formula. And then here's the predicted motion for the gravity only one. So we can see that the velocity is decreasing constantly since the acceleration due to gravity is constant. And then here's another computational model for the gravity and also the drag force. So on the left-hand side, we only change the little b. I make it equals to 0.047 based on like the observed time and also positions. And also on the right-hand side, we need to change about how to update the net force. So we need to also include the forces for the drag, which is b times the magnitude of the ball's velocity squared. Yeah. And we add up the gravity and also the drag force together to make it to be the net force. And all the other part are the same. So the predicted motion for this is like we can see on the right-hand side, the velocity tends to flatten in the end like that. So yeah, and I will discuss that later. So here's the observed versus predicted model. And we can see that the observed one, which is the blue line, is pretty close with the gravity plus the drag line, which means like in the real time, we have the air resistance acting on the product object. And for the gravity one, it's going a lot more distance, and it's kind of off with the other two lines. And also I need to mention about like some possible sources of error. So first one is about human error. Yeah, when I release the object, probably I also add some other forces on that, and there's maybe some other like measurements error when I record like the time. So here's the what if questions. Let's compare like the without drag and with drag for the velocity versus time. So we can see like without drag force, the velocity is constantly decreasing. But for the with drag one, we can see that the velocity turns flatter in the end. So we can know that the terminal velocity can be predicted with the with drag one, since that also is kind of similar with our observed result. And when the force of drag pointing up has exactly balanced the force of gravity pointing down, then the net force in this case is 0. So what if the object was initially thrown downwards? I also modeled that in the code. So I set the initial velocity to be -2 on the right, and it can be like showing this graph on the right. So we can also see that the initial is pretty large, but it also like the velocity tends to flatten pretty quickly compared to the left one. So the terminal velocity are both around like -3. So we can like claim that there's a node effect if I throw that with some initial velocity. And thank you for listening. That's all.